What do MRI, Wi-Fi, and JPEG images have in common? French mathematician and physicist Joseph Fourier found the Fourier series and transform. Fourier series states that all waves can be broken down into a sum of sine and cosine waves. First, let's compare this sine wave to this square wave. They look nothing alike, right? But I'm going to add a new sine wave to this and graph the sum of the two waves. When we're graphing the sum, we'll add up the two y values that have the same x value and plot it. Does this look more like a square wave? Not yet. What if we add a lot more of the sine waves? There are 10 sine waves in this graph and it looks pretty much similar to a square wave now. When we look at the equation, we can see that in reality this only added up sine waves. Using this technique, we can create sawtooth waves and triangle waves as well. Now it's time for Fourier's transform. When we hear sound, I'm using sound waves here, but this really works for any waves, like heat waves or seismic waves. When we hear sound, we can graph it like this, with the x-axis representing the time domain and the y-axis for the amplitude or strength of the sound. When we have multiple sounds at the same time, it will look something like this. It looks very messy. But what if we want to look at a specific frequency and remove it? Well, that's when Fourier's transform comes into work. When we regraph it so the x-axis represents the frequency and the y-axis for the amplitude, we can now easily single out the frequency that we are looking for. Once we see the frequencies, we can easily remove or reduce the frequencies. In fact, this concept is used for your noise-canceling headphones as well as Zoom's background noise-canceling feature. Going back to the beginning of this video, the concept of Fourier series and transform is used widely in the medical field, such as for nuclear magnetic resonance or NMR and magnetic resonance imaging or MRI. It's also widely used in our daily life in the form of Wi-Fi and JPEG images. It's basically everywhere. Elements we commonly used had incorporated an element of Fourier's transform in it.